This
So first,
conference will now be recorded.
yeah, first I would like to welcome you all guys for this session. I never expected like a crowd of I don't know, more than 100 people will be joining. Like it's pretty exciting for me. So in this session, like I will be taking you through a journey where I will be explaining the basic concept of an object-oriented programming. So I will be using Java for explaining those concepts in a syntactical way. So in case if you have any doubts or if you didn't understand anything, just make a note of it. And at the end of the session, like you can ask me and I can clarify those doubts for you. So about me, I'm Sudharsan Selvaraj. I'm working as a senior test engineer at Dell Boomi at Bangalore office. So I have around 6+ years of experience in test automation. I've been working in tools like Selenium, Protractor, Docker, Jenkins, and Java and TypeScript, all the languages which I primarily use. You can follow me on both LinkedIn and GitHub with user ID as Sudarshan Selvaraj. And I also recently started a YouTube channel focusing on posting interesting content on test automation, not just the usual tutorials which you see in YouTube. So you guys can subscribe to my channel and see those exclusive contents. So let's see what all the things I'm trying to cover in this session. So first we will be seeing what is an object oriented programming and what's the need for it. Next, like what is a class and what is an object, how in object oriented programming we will be creating a classes and how we are using the objects. So I will be explaining those things. So the same I will be trying to give a real time example so that you guys can easily relate to the concepts in the programming as well. Then some of the oops concept like abstraction, encapsulation, so those things I will be covering as well. And at the end we will be having a question and answer session where you guys can ask your doubts. Cool. So everyone at least once in your career might have come across this word called object oriented programming. It may sound very bit confusing, but if you understand the concept, it's a very simple. uh, every concept in programming is derived from your day-to-day things which you do and which you see. So similar to that, object-oriented programming is also a programming paradigm. That's a concept that relies on the concept of classes and objects. So let's take your day-to-day activity. Without objects, you cannot perform any operation, right? So starting from your day to you go to bed, everything which you do depends on any of the object. Let's say you have a pen, you have a pencil, you have your laptops, you have a mobile. Everything is an object. Likewise, in object-oriented programming, everything we use is an object. So without object-oriented programming is not possible. That's the first point. So in object-oriented programming, computer programs make use of objects that talk to one another and to change the data in those objects. So when I say objects, each and everything will be a tiny objects and they will start communicating between each other. Like how you have, so let's say Sudarshan is an object and Amod is another object. We both are communicating in the real time, right? So if I have some data, I will be sharing it with Amod. If he has some data, he will be sharing it to me. So that's how in real time object works. Same case applicables to programming languages as well. There are objects, they will communicate each other to exchange the data or manipulate the data. So object oriented allows you to control the state of the data more efficiently. So in typical programming, like if you see any structural programming or functional programming, the the most difficult part is to maintain the data, how to maintain the state actually. So that's the key problem that we are facing in the older programming languages. So in object oriented programming, it will be more efficient to maintain the state of a object. So this is a basic of an object oriented programming thing. So in as I said earlier, in object oriented programming, everything is an object, correct? So in your real time, if you take a pen, pen is an object. But how that pen is constructed? So in real world, you will often find many individual objects are of same kind. So if you take a pen of a particular model, let's say Parker pen, you can see same model of sorry same instance of the pen available in in a huge number, like thousands and 10,000 of the same pen is available. But how the pens are made exactly look each other, and they have all same properties, right? So that is where the class comes in picture. In object oriented terms, a class is a blueprint from which individual objects are created. So if you are a pen company and you want to make a pen, first thing you do is you come up with a plan or a blueprint on how that pen looks, what are all the behavior of the pen, and what are all the things you need to be considered while making a pen. So that is what the blueprint. Once the blueprint is ready, you can start making any amount of pen you want based on that blueprint, and all the pen that are made out of the blueprint will share the same properties and same behavior. You get my point, right? So a class is nothing but a blueprint of how an object exactly looks. In programming language, we will call this blueprint as a class, and the instance of that class is called as an object. Okay, so let's compare it with some real-time object. So let's say let's take a human as an example. Every object shares two items. Okay, the first item is called as a state or a property. The second thing is called as a behavior or action. So this is applicable for any object you take. So in case of a human being, what are all the state or properties he possesses? So let's say there is a property called gender, height, weight, skin color, hair color, eye color. So these are like some of the properties which this object has. And what are all the actions that object can perform? So human can eat, he can sleep, he can walk, he can study, he can play, he can read, he can do certain set of actions. So if you take a car, it that particular object has a different set of properties and a different set of behavior. So for a car, what are all the some of the properties are like what color it is, what model, make, and what is the fuel, whether it is operating on a petrol or diesel, what is the number of seats. These are some of the properties that is applicable for a car. And what are all the actions that can be performed on this particular object is we can start the car, we can do accelerate, we can change the gear, we can go reverse, we can apply brake, and we can stop. So all these actions are applicable to this particular object, correct? So if you want to represent a real time object, you will be explaining to someone like this: okay, an object that looks this color looks like this with the number of seats, and this can perform these set of actions. In programming world, to now let's try to like represent the same object in a programming world, like, okay. So the states and properties of the object which I explained in the real time is represented as a variables in the program. So whatever the state or properties a particular object holds will be represented as a variables, and the behavior or action that can be performed on a particular object can be represented as a functions. So basically a class is nothing but a blueprint that holds a variables and functions of that particular object. What are all the properties that object can possess, and what are all the functions or operations that particular object can perform. So a class will contain these both information. Now let's see how a simple class look like. So this is a class for that particular human. So it starts with the keyword called class followed by the name of the class. Let me take a pointer. Okay. So the keyword class tells the Java compiler like this is going to be a blueprint, and the name of that class is going to be human. And these are all the list of properties this particular object going to have, and these are all the list of actions that can be performed on that particular object. So in case of human, uh, forgot about this. I know this is very basic. Like this is the data type of that particular property. So so in this case, like we have a gender, height, weight, hair color, skin color, and eye color, and we also have some functions called eat, sleep, and walk. So in case of car, we will be following the same syntax. We will start with the keyword class, followed by the class name, and we'll define the set of properties, and we start defining the set of actions that can be performed on the class. Here we have what is the color, what model it is, what is the fuel type, and what is the seat count, and what all the operations are, like we can start, accelerate, shift, reverse, and stop. So these are all the actions. So this is how you create a class, you define the variables, and you have initialized the initialization, you have defined the functions here. You got it right? So this is how a class can be constructed. But still, what we need to do is, like, we need to create an object. With just the class you cannot do any operation, right? It's just a blueprint. Only after creating an object of this blueprint you can do any operation on that particular class. At this point it is just a blueprint, you cannot do anything on it. So next thing is, like, we need to create an object from the class. When you create an object, you are creating an instance of a class, therefore instantiating a class. That means, so let's say you have a building, so that building has a blueprint on how exactly the building gonna look like. But once the blueprint is there, you will be hiring some engineers, and with their help you start constructing the building, right? Only after the completing the construction you will have an object in your hand. Unless you start constructing the building, you will just have a blueprint, you cannot do anything with the blueprint. So we will be creating an object with the blueprint there. The new operator instantiates a class by allocating memory for a new object. So a class does not holds a, during runtime a class doesn't hold any uh, memory in the pool actually. Only when you start creating an object, that object will be allocated a different memory and it will be placed in that memory actually. So unless or until you're gonna create any object of that particular class, it does not occupy any memory. So how we will create a class is by using a new operator. So let's see. Okay. So here, in this example, you can see I am creating a object for the class as human. There are three parts to it. First part is the declaration. The code human Sudarshan. So this part is a variable declaration that associate a variable name with an object type. So what I'm telling here is I need a variable with the name Sudarshan of type human. So I am declaring a variable here. Next part is instantiation. The new keyword is a Java operator that creates the object. So first, this is a variable. Second part is with the help of a keyword new, and I'm telling which class I need to be instantiated. It will create a new object for this particular class and it stores in a memory. That is what called as instantiation. The third thing is called initialization. So I have a variable, now I have an object. The third point is the created object will be assigned to this particular variable. So that is called as initialization. So you got it right. First we will mention what type it is, what the variable name it is. I am telling you should create a new object for me, and you are mentioning which class you want. So for this particular class, it creates a new object and it assigns it to Sudarshan. So this is how you will be creating a class in Java. Okay. So now we have a class. So now we have an object. So now we have successfully created the
Sorry to
object.
interrupt, Sudharsan.
And how you will, yeah,
Just want to add
yeah,
some
go ahead. Yeah,
points here. So,
sure.
you explain the class and object well. Okay, fine. So let's see that from where it is coming actually. Let's forget the concept whatever we learned just now. Just see, like, suppose you are owner of a company, right? And will hiring some people. Okay, like you call it employees, correct? So every employee will have some data like their name, their salary, their gender, their some personal informations and all. Right? Suppose when you have one or two or some 10 employees, then you can maintain a register to uh, keep those data of employees, correct? And suppose if a new employee is getting married, so you go to your register and update. Okay, this guy is married. Okay, but your register is accessible to anyone. Anyone can see it. If someone get the key of that locker, anyone can take that file and can use this one. Okay, so the problem what is happening, like suppose when the company is growing, right? So many new people are joining. Okay, so it's very difficult to keep the data of all the employees, correct? And every employee should have the common set of data, like the name, address, everything. These things are common for a employee. Okay, so here if you think that okay, we the owner of the company started thinking, I need some way or I need some mechanism where I can keep data as a individual. Okay, like employee one has this data, employee two has this data. Okay, so what they have done, okay, so if any employee joining to my company, I will keep some details of this particular employee, like the name, address, gender, marital status, salary, and everything. Okay, so generally these things are considered as a property of that employee. Okay, any employee can work, like employee is a developer or coder or something, testers, right? So it defines some functionality or actions of that particular employee also. Okay, so what the owner did, he just created a blueprint where he defines, okay, I will collect these details of a employee, and whenever new employee comes, I will give this a form, fill it, so that I can get a data. Okay, so this is also like in this every employee is an object. Okay, here, and whatever blueprint we have created, that is called actually class. If you're going to book a train ticket, right, every person get the same type of form. Okay, those forms is generated from single blueprint. Okay, so that everyone is getting the same form, right? So that is the thing, like blueprint is a factory where you can create the identical objects. Okay, but if you go in advance, so you will find some more details, like when you use the constructor, so every object can have different property. Okay, like employees, right? Generally, developers are getting paid more than testers, correct? So developer will have the higher salary, but they will belong to one blueprint only. But their property called salary will be different for both the employees. Okay. Yes, Susan, sir, please go ahead.
Yeah, sure. Yeah. Yeah, so let's consider so this is going to be application form. Let's consider uh, like details of a particular person. So I have created a new instance of that particular application form. That means this particular object gonna hold details of Sudarshan. So let's say as Ahmad explained, you go to railway station, you pick the application form, you pick two applications form, one for your friend and one for you. So when you start filling the application form, it becomes an object. So there was a blueprint. You printed multiple applications form, and you started filling. And each of the application form holds a different set of informations. Your application form will have your own information, whereas your friend's application form will has his own information, right? So the blueprint is going to be the same. Object is also created, which are identical, but the data which the objects having are different. So you're getting my point, right? So in this case, I am creating a new human called Sudarshan, and I'm assigning the gender as male. You can also create one other human called like X, and you can assign the gender as female. So in this case, with the same class, we are creating two different option object which looks identical, but the data are different. So and this is how we will be accessing the variables and the functions. Object name dot variable name or object name dot function name. So this statement is used to assign a value to the variable, and this statement is used to retrieve the value of an variable. So you can get it, right? So first I'm assigning the variable, and I'm using a sys.outer println to check what value this particular variable holds. So this is how we will be accessing the variables and the methods from a object. So these are like the basic thing: how to create a class, how to create define properties, how to define the functions, how to create the object of any particular class, and how to interact with the variables and functions of that particular object. So these are all the primary things. So whenever you take a Java, with either you create an object or use an existing object, you work by calling the methods, or you get the variable, or you update the variable. So these are all the common actions that you're going to perform in the Java programming, whatever the program it is going to be, like if it's going to be test automation or development or whatever it is. So these are all the primary key operations you're gonna do. Okay. So moving on, there is something called object-oriented programming concepts. So these are some of the additional features that is available in object-oriented programming. This is not just to Java. These concepts are applicable to all type of object-oriented programmings. So what are all the things are like data abstraction, encapsulation, inheritance, and polymorphism. Okay. So I will be explaining each and everything with a simple real-time example. So first is called abstraction. Okay. You can like interpret abstraction in real time as a hiding. Okay. In object oriented design, programs are often extremely large and all objects will communicate with each other a lot. So you know this at this point. We have multiple objects and each object is going to communicate with each other. So they're going to share data, they're going to pass some informations to do some certain actions, they get some data to perform certain actions. So that's how in object oriented programs objects going to talk. Applying abstraction means that each object should expose only a high level mechanism for other objects to use. So what this means is, so let's say Sudarshan can perform n number of actions. So Sudarshan if Sudarshan is in house, he can perform 10 operations. When Sudarshan is in office, he can perform 10 different operations. Okay, if I'm in office, I can write programs, I can manage my team, I can attend sessions, and etc. If I am in home, I can talk with my friends, I can interact with my parents, I can watch TV, I can sleep. These are the some of the actions which I can do it in home. Now consider an object which has different like n number of operations, but only apart from the n number of operations, we should be exposing only the operations which are required at that moment. So when Sudarshan is in office, I don't want to expose methods like sleep or watch TV or something. In office, the methods which I required is do code, attend meetings, or manage the team. So those are all the operations which I need to uh, expose to the outside world. So by the way, by some means, I am hiding few of the items from an object. So that is what abstraction means actually. So the key point of using abstraction is to hide internal implementation details. It should only reveal operation relevant for the other objects. So let's see an example for it. So see. So let's take our mobile phone. It has certain number of operations like we have a home button, we have a volume button, we have a volume up, volume down button, power off button. So these are all the some of the operation under touch screen. These are all some of the operation that phone has. But if you take look deep inside, if you press on a home button, internally it is performing lot of actions to get that work done, right? So it's not like simply if you are pressing the home button, it's not coming to the home. Internally it does some operations, but it is not visible to the user and it is not necessary to be visible to the user, right? For end user, you need a way to tell something and it does some operation, but it is not mandatory for the user to know what exactly it does. So it's a way of abstracting the behavior. Same for volume button. You just press the volume button, the volume is getting decreased. But internally you doesn't know how that volume decrease operation is carried out. So if you take a car, you have an accelerator, you press the accelerator, car moves forward. But you exactly don't know what happens inside the engine which makes the car to move forward, right? Because you don't need those informations. You just need an accelerator and you press the accelerator, car will move forward. So this is the main area where abstraction is applied in programming language as well. So next is called encapsulation. So encapsulation is achieved when each object keeps its state private inside a class. So other objects doesn't have direct access to its state. So let's quickly see this example. Okay, so let's say I have a class called human, and it has gender, height, weight, everything declared here, and we are creating an object called Sudarshan, and we are assigning the gender as male. At this point, in this particular Sudarshan object, anyone can go and update the gender as male, because I haven't encapsulated this gender variable. So that means this variable is accessible to anyone. If someone gets this object, they can go directly manipulate it. You are getting right? So there should be some mechanism where you can maintain your states privately, and you will be giving some other ability to others to access it or modify it. So that is what called as encapsulation. So instead they can only call a list of public functions called methods. So instead of directly going and updating a variable called gender as male, you will be exposing few functions. Can you guys please mute your microphone?
Darshan, you are not audible.
Hello?
Yeah, better now.
Yeah, sorry. Okay. So this is like a classic example for the encapsulation concept. Let's consider a vending machine, and vending machine holds n number of items there. User can see what all the items are there, but they cannot directly access it. So if you see there are n number of chocolates available, n number of drinks available, they can see it, but we cannot directly access that object, right? How to access the object is using certain functions. This machine exposes a function through which you will be trying to access the variables. So this function will have certain logic, whether to give access to this variable to this particular user or not. So that depends on the application. So in this case, you have to insert money or insert a card, enter the pin number, it validates the pin number, and only if the pin number matches, then the data will be handed over to the user. Unless or until the data is invalid, you will not be granted access. So this is one way of encapsulating the data. Okay. So next is inheritance. So this is one
Sure.
of
Can you,
the yeah.
so sir, can you go to back
Sir, can you
previous
explain
slide?
encapsulation also?
Okay. So this particular image, right, encapsulates an example that vendor was seeing, right? So actually, if you see that this particular real-time example is representing the both the concept like encapsulation and abstraction. Okay, how? Because if you see these items, right, that Pepsi, Coca-Cola, and then some Kurkure and all, right. So those are actually like data members, okay, of that particular of a class. So that you cannot directly access it. You need to pay. You need to do some payment. Then only you can get the access on those products. So that is encapsulation. How it is representing that, it's abstraction also, because you don't need to know how this particular machine is working. You just need to do the payment by any way, and you will get the product. You are not worrying how this particular vending machine is working. So this particular example is showing both the oops concept, encapsulation and abstraction. Okay, so in maximum real time example, these if someone is explained its encapsulation, so somehow that particular example will show that it's abstraction also. Okay. Yes, Russen, go ahead.
Yeah. So like I may also like give
Hello,
you a simple
hello.
yeah. Hello.
Can you explain this concept with the automation? Hello.
Yeah, actually, this is not
Uh,
something which is related to automation. This is okay. I will first like give you a simple code snippet so that you can easily relate to it.
So, we'll take this
okay, okay, sure.
in the last. So first we
Okay,
finish the slide, then we can
sure.
take
Yeah, yeah,
this,
yeah, sure.
because these concepts are not specific to automation or some
Yeah,
developing. These concepts are like related to OOPS. Any programming language supporting OOPS, you should know that what is these concepts. Okay.
But while implementing framework and all, we have to use all these kinds of this kind
Yes,
of
because
concepts only.
see,
So
that
that's
is
why
the thing. Whenever you're creating
I'm
framework
asking.
or whenever you are writing some scripts, you are using this concept indirectly, but you never know that you are using some oops concept. That is the problem where people are not able to explain in the interview. You have used all this concept, but you don't know what is that, what is the basic meaning of that. That's why you're not able to explain. Okay, so let's understand the basics. What is meaning by oops concepts? Then we'll show that how whatever code you write in your automation script or whatever wherever you write, that exhibit one oops concept. That is the concept. That is the fact.
Okay,
Okay.
okay,
So let's
okay,
continue
okay,
with
sure.
this. Then we'll cover everything. Don't worry.
yeah. At the end, like I will be giving you a simple code snippet example for each of the concept, and I will like try to connect with these slides. Actually, we can do that at the end. So the next concept is like it's the inheritance. This is one of the main concept I would say. In object oriented programming, most of the time objects of different classes share the same logic, but they are not entirely the same. So let's say um, let's take a company. There might be different employees, right? So there is a manager level employee, there is a individual employee, there will be a contract employee, there will be housekeeping employees. Like we will have different type of employees. So to represent those employees in a programming world, we will be creating different classes. So first we will create a class called class manager, and it will contains all the properties for a manager employee. Next, what we will do, we will create a class called contractor, and that particular class will have all the properties for a contractor employee. So likewise, whatever the employees you have, you will be creating a different classes, and each class will have its own properties and its own methods. Now, in inheritance, the class which is given data members and methods is okay. First, I will show the example and I will explain this. So as I said, I forgot about this part. So now we have four different type of employees. Each employees will have certain properties like a name, gender, age, employee ID, their address, their designation. So this is common for all the employees. So how your class will look like? You will have four different class, and all four class will have these common properties embedded to them. Class manager will have name, age, gender, designation. Class of contractor also will have name, age, gender, everything. And also a housekeeping employee will have name, age, gender, address, everything. Now what's the problem here is employee is a common class. Like all the object represents some common class, and they all share few common properties. So instead of defining those properties in the individual classes, we will be extracting those common properties, create a new class for their common properties, and each of the employee class will extend that common properties. So if you can see in the example, there is a common class called worker. So these are all some of the methods all the workers share. So they have a daily routine. They will get up, they will eat breakfast, go to work, they will work, return to home, relax, sleep. So all these functions are applicable to all type of workers. So we are extracting this information and we have created a class called worker. Now we have n number of workers. We have a firefighter, we have a lumberjack, we have a postman, and we have a manager. What this particular class is doing is it is extending its properties from worker class. So extending means it has its own method, and also it can reuse the methods from its base class. So the class which shares its information is called as base class, and the class which consumes the information is called derived class. So in this case, worker is the base class and firefighter is going to be the derived class. So in case of it's a manager, he has all these operations. In addition to it, he has an additional operation called relax. This is only applicable to manager class. So this way we are like grouping all the common properties into a single class and extending it based on our needs. By this way, most of the duplication in the code can be removed, and eventually it will be very easy for the maintenance. And in case of something needs to be updated, instead of going and updating each and every classes, we will just go and update it in the base class. That way all these changes will be reflected in the child class as well. So this is called as inheritance. So next is polymorphism. So polymorphism
Sudharsan,
is, yeah,
Sudharsan,
go
I
ahead,
want
yeah.
to just add some point in it.
Sure, yeah, yeah, go
Uh,
ahead, yeah.
okay. So okay, like suppose when you are walking on roadside, so you see so many cars, right? So you are generalizing as a car. Once when you are saying that it is a BMW car or it is Audi, okay, or some other company, right? So like, but everything we can simply say it is a car, correct? And when I say you car, so you visualize it, right? How you visualize it? Like a car should have four wheels, right? One fuel tank, one steering, right? Something you define that there's something common across all the cars, irrespective of which company it belongs to, correct? So generally, what is the programming concept says that if something which you are going to repeat in each and every class, okay, so don't do that thing. That is best. That is not the best practice. Do one thing. Take collect all the things which are common, okay, and keep in one class, and then you just establish a relationship. Okay, whatever new classes I'm creating, this class already contains a property of this particular class. So you need to just define the unique things. Like suppose BMW is giving the GPS enabled some tracking, so that is unique to BMW car. Okay, now Audi is giving something like driverless driving. Okay, so this is specific to Audi, but every car is having the common properties, right? And whatever the company is providing some unique feature, that is specific to particular class. So this is also called like inheritance, where you keep the common property at one place and then you inherit those things and you just add the new property to it. Okay, yes, Susan, please go ahead.
Yeah, cool. So the next concept is called polymorphism. So polymorphism can be translated as many forms. So taking many forms. That means a single operation can be done in different ways. So that is called polymorphism. So in Java there are like two types of polymorphism. One is called compile time polymorphism. Another one is called runtime polymorphism. Okay. So let's see what it is. So let's take a class. Okay, if a class have multiple methods by same name but different parameters, it is known as method overloading. So one of the compile time polymorphism which is used in Java is like method overloading. So let's take this example. I have a class called calculations, and there are two methods with the same name. First method is sum, which accepts two parameters. Second method is also it's sum, but if you take the parameters, it accepts an array of integer, whereas here it accepts two integers. Here it takes array of integer. Now, when we try to call that object, some method here, so object dot sum of 20 comma 20, this call will point to the first method, and this particular call will point to the second method. So how this particular mapping happens is during the compile time itself. When you compile this particular code, compiler itself will map this particular function call to the respective functions. So a same method with different parameters is possible, and the mapping of the call is made during the compile time itself. So here the same function has two different set of operations here. So that is called polymorphism. Since it is done is during compile time, it is called compile time polymorphism. So and also this is known as method overloading. A method with same name and a different properties is called as method overloading. In runtime polymorphism, it's like similar to the method overloading, but whereas the call will be mapped during runtime. During compile time, it doesn't know where it should call, but during runtime, it predicts. So I will show you this example. So let's take a class called animal, and it has a method called sound to it. Now we are going to create a specific animal called horse. This is a class horse that extends the behavior of a animal. In general, the animal sound is like animal is making a sound because it doesn't know what sound the animal is going to make. So generally we are telling us animal is making a sound. But in case of horse, we exactly know what sound that horse is going to make. So we are overriding this particular method. Even though this method is already available in the base class, we are redefining the method and we are telling, okay, horse is going to sound like this. And while calling the object, we are creating an object of this particular class and we are trying to call the method as sound. During compile time, compiler will think this particular sound represents to this particular class because we are creating an object and assigning it to class called animal, and animal.sound will point to this particular method. So as far as compiler is concerned, it doesn't know which sound to call, whether to call this sound or this sound. But during runtime, since we have created an object for this particular class, sound method will be called from the horse class itself. Instead of calling the animal class, the sound method is called from the horse class. So during runtime, it automatically predicts which method to call, and the output we will be looking is like this. So this is called as a runtime polymorphism or method overriding, whereas you are overriding the default behavior of this method from the base class. So a base class has a method and a child class extends the base class and it overrides the functionality or the behavior of the parent class method. So this is called as function overriding, whereas overloading is in the same class if you have two methods with the same name but which can accept different parameters to it. So this is called as overloading. So these are all the four important concepts that is there in object oriented programming. So abstraction, encapsulation, inheritance, and polymorphism. So I guess that's it pretty much, guys. So Amit, you want to add anything up?
Yes, Sudharsan, I want to add for
Yeah.
the polymorphism. So, if you
Okay.
say that
Yeah.
what is the base example of polymorphism? So, um, what what you people can say, right? For the base example of polymorphism in real time, leave the programming concept just in the real time. So, the base example of polymorphism are engineers, right? It doesn't matter if you're an IT engineer, you just need to work in IT company only. Any engineer can go to any public like any private job or any government job. They can do any work, right? They have the title engineer, but they can do any work. If you see the bank PO or you see the IES IPS, many are engineers there, right? So engineers are one, but they can do multiple works whatever they want. So that is the perfect example of polymorphism. Okay. Yes, so Susan, can you share some code examples also so that people will understand better?
Yeah. I will start from first. So let's start from abstraction actually. Okay. So let's first create a class called abstraction. Okay, let's go with okay. So let's consider a class called a person, and person can have a what all the operations a person can do is like public void eat. This is one operation. So public void walk, public void sleep. So public void study, do homework, write exam. We can say work. Let's say attend interview. So these are some of the common functions a person can do in a real time, right? So now let's create a new class called office school and home. Okay, so in case of office, so person Sudarshan is equal to new person. So in office there is a person called Sudarshan, and when office tries to give me some instruction, it can ask me to do any of this instruction. It can ask me to eat, it can ask me to sleep, it can ask me to study, work, everything. Same applicables for school. A school is a class. It also creates a object for Sudarshan, and it can also see list of things which Sudarshan can do here. Sudarshan can work, Sudarshan can write exam. But the thing is, in perspective of a school, it doesn't want the person to do any work, right? It doesn't want the person to do eat or something. It only concerned about study, do homework. That's the only thing as far as school is concerned the person should have. It doesn't want the person to do any work or something. Same for office. In office, only the object what it can do is like it can work or it can walk. So office cannot tell a person to study or you do a homework or write an exam or something, right? So we need to somehow uh, uh, control the methods which is exposed to the outside world. So how to control is like we can use interfaces to one way to control the do the abstraction is by creating interfaces. So let's create a called office person. Under this office person, I can define the list of methods that is only accessed by office peoples. What all the methods are like public work, void work. So now, if you see, instead of person, if I declare, okay, so now this particular person implements the office person. That means whatever the functionality an office person can do is defined in this person class. The office person can work, and the person class has a method called work. Now in office, I'm creating a person called Sudarshan, which is of type office person. And if you see, I can only see work here. So there is no do homework or write exam. So those methods are not exposed here. I'm only exposing the things which an office is required for that particular person. In case of school, we create a new interface called school person, and we only require study, do homework, write exam. So now this person is also implementing the school person. So what a school person can do is he can study, he can do homework and write exam. And in a school, we will be creating an object with school person. And if you see what all the methods are accessible is only he can do homework, he can study and he can write exam. So the methods for work, eat, sleep are abstracted here. So same for home person. What we'll be creating is we will create a new interface for home, and we only expose those method that is required in home. So that way, not all classes have access to all functionalities. So those are abstracted there. So hope you guys can understand this. Amod, your point?
Yes, Sudharsan, you have,
Yeah. So this is cool, right? So
yeah.
next we can go for encapsulation. Okay. So go with the package called. Okay. Okay. So we can take the same example as person. So instead, I will remove these things. So let's say I have a class called person, and let's define few variables. What the person can have. I can have name. I can have gender. I can have age. I can have like work, whatever it is, string, occupation. So now all these variables can be accessible by outside world. So that means person equal to new person. So now if I say person, I can access all the information of that particular person. I can say his age is 10. I can say his gender as male. I can say his occupation as software engineer. So whatever it is. Now I have created a person. But what's the problem is, so let's say there is a person with all this information. We should not allow someone else to go and update his property, right? So someone cannot directly tell this, no, this person is not a female, male, he's a female. We cannot go directly update this person's occupation as some government official or unemployed or whatever it is, right? So to avoid accessing it's an object state, we will be using encapsulation so that these particular entries are not accessible. So how we will be doing it is by using access modifiers. So since these attributes are public, we will be making it as private now. I made these things as private. Now if I go and see I cannot access it because only the class which holds this data can access it. Okay. But now the problem is I want to set some data on this particular object. Since these variables are private to the particular class, we cannot directly access or update this variable. What we will be doing is we will expose some publicly accessible methods. So in case if you want to get the name of the person, we will expose a method called get name. This will return the name of the person. Likewise, if you want to change the name of a person, we will expose another method called set name, which accepts the parameter as name. And we inside this class we will be assigning it to the variable. So now if you go to this example, I can set the name as p dot set name of Sudarshan, and I can say p dot get name. So see, now we have a control over how the values can be updated, right? Now we can add a logic here telling only if the name is Sudarshan we will be update, otherwise we don't want the object to update the name. So if name dot equal ignores case Sudarshan, we will assign it. Otherwise, the name will not be assigned to this particular variable. So in this case, if I pass some random name as Java, this particular initialization will be ignored because we had a condition. So only a name can contain the possible value of Sudarshan. If it is apart from Sudarshan, we don't want it to set it to the variable. So this is what encapsulation is. You are determining what are all the state that can be exposed to the outside world of that particular object. So this is basically called as encapsulation. So as I said, these are all the variables. Now we have made all these variables as a private, and we have exposed a method called a get item. So we will add that logic here. So like how we add the set name, right? We will add a logic here to check whether the card payment is successful. Only if the payment is successful, so we will be adding it here. Let's say if only if the payment is successful, return me the item. Otherwise, I will say I will return empty in case of payment failed. So this way you cannot directly access the variable. You call this function, and this function does certain operations, and it will determine whether or not to expose that variable to the outside world. So this is called encapsulation. So next concept. So you're clear, right, Amod?
Yes, yes.
Yeah, cool. So next we will take an example for inheritance. So for inheritance, so let's create a class called manager employee. Let's create another class called engineering employee. Let's create a new class called contract employee. So first let's define the properties of a manager employee. So a manager employee can have a string name, string employee ID, string gender, string address, and he has additional properties called which department he belongs to or which department he manages. This is called department he manages. So we may call this as private, and we will expose the methods generate So we have methods like get name, set name, getting employee ID, setting employee ID, all this for manager employee. For engineering employee also shares the same properties, but he doesn't have department he manages. Apart from that, he requires all other properties like name, employee ID, gender, and address. Same applicables for contract employees. Okay, so now we have three different employee class which has its own set of properties. Now let's create a new Java class called main. So first let's create a employee for manager employee equal to new manager employee. Same for engineering employee equal to new engineering employee. Then a contract employee equal to new contract employee. So now if you take manager employee, we have methods like get name, set address, set name, everything. So let's set address, set name as manager, and for engineering employee, set name as engineer, and for contract employees, we can set as contractor. Okay. So now the company decides to introduce a new field called, so let's say due to this COVID-19, they want to introduce a new field called whether the particular employee has undergone a COVID-19 test or not. So to add that, what we will have to do is like we have to go to manager. We will be adding a class called private boolean is test done or is COVID test done, and we will be exposing two new methods. So we will be copying the same for engineering employee as well. So we will be doing the same for contract employee as well. So now you got the problem statement, right? All the employees have certain properties, and if a new properties needs to be introduced, we have to go manually update each and every employee class. So if something wants to be removed, we don't want address going forward, we don't want to track address, means we have to open each and every class. We need to delete these properties. We have to open engineering. We need to delete address properties. So to overcome this problem, we introduce a new concept called inheritance, where all shared properties will be moved to a common class, and each of the child class will inherit the parent class. So let's say I will be creating a new called base employee, and we will be moving all the common logics from this to this. And now we have a class called contract employee. This particular class extends its properties from base employee. Same for engineering employee. Now we don't want any of these. We'll simply say I'm extending the properties from base employee. Same for manager here. I will remove all these. I will remove all these, and I will say extend the properties from base employee. Now if you check the main program, see there are no errors. Even though this particular manager employee doesn't have a method called set name, it doesn't throw any error because this particular set name is inherited from the base employee. Now if I say I'm going to add a new property called public uh, int attendance, or a number of working days, and I will expose a method. That's it. If I go to the main method and if I check manager employee dot get number of working days, I can get this method here. If I say engineering employee dot get number of working days, I can access the method. So this way we are like dividing the class based on its functionality. So now base employee will have all the functions and attributes that every employee holds, and in child class it will have the functionality only specific to that particular class. In case of manager, he has an additional ability to get the department he manages. In case of engineering employee, he has additional uh, property called public string what technology he is working on. We will expose a method for this. So if you go to the main, in manager employee you can see set department he manages. In case of engineering employee, you will not see that set department he manages. Instead you will say get technology and set technology. So you're getting the point, right? So common properties will be extracted into a single class, and the child class will inherit it from the base class. So in here in the example, base employee is called as the base class, and the manager employee, engineering employee, and contractor employee is called as the derived class. So this is called as inheritance. So there are like different types of inheritance, like single inheritance, multiple inheritance, multi-level inheritance. Those are like some additional concepts that like you can search in YouTube for those things, and you can learn it. So this is the idea what inheritance is and why we need the inheritance. Cool. So and the last concept is polymorphism. So I can simply explain it with polymorphism. So I have a method. Let's say let's create a method called okay. Then I will say public void public int sum. So it accepts called int a comma int b. So it should return me a plus b. So I will say polymorphism equal to. Now let's say sys.out.println polymorphism dot sum of a comma b instead of 10 comma 10. So if I run this program, I, so we can see the sum is printed as 20. Now if I change its value, the output is also going to be changed. But take a calculator. In calculator, it is not mandatory, right? You can only sum two numbers, right? You can like enter any number of values and you can keep on pressing the plus symbol and it keeps on adds. So for that purpose, we will be defining another method called sum. But here, instead of it accepting two parameters, it can accept an array of integers. So the numbers. So this will return sum of all the numbers here. So for so let's say int total equal to 0, for int n in num n, and it will return the total. So now I'm calling the same method called sum, but instead of passing two parameters, I'm passing a single array of parameter here. I will be passing 10 comma 10 comma 10 comma 10. And if you see the output, so the first one is telling 10 plus 13 equal to 23, and the second method tells that the sum is 40. Here, this particular call list, right? This call maps to this particular function, and this call maps to this particular function. This mapping is done during compile time itself. So while compiling the program itself, this particular statement will be pointing to this particular function, and this particular statement will be pointing to this particular function. So this is called as compile time polymorphism or method overloading. We are overloading the method. The name is same, the return type is same, but if you check the parameters are different here. So this is called function overloading. The other thing is runtime polymorphism is called function overriding. So for that, let's create a class called animal, and let's create another class called dog. So in animal, I am defining a method called public void make sound. So at this point, I don't know what, like, this is just an animal. We are not sure like what sound it's gonna make. So we can print like I'm not sure what sound to make. Okay. So now let's create an object for animal equal to new animal, and let's call animal dot make sound. So it's telling I'm not sure what sound to make. This makes sense. Now we have created another class called dog that extends animal now. Now if you go to main, let's create an object for dog. Dog dog equal to new dog, and I'm telling dog dot make sound. In this case also we should see the same output. Yeah, we are getting I'm not sure what sound to make because this particular dog class reuses the same make sound method. But now we know that what dog exactly sounds like. So what we will be doing is we will be overriding that particular method from the base class. So we will say public void make sound. This is annotation override which tells that this method is overridden from the base class. Now we say system.out.println woof woof. So this is how dog sounds. Now if we go to the main program, if I run this, you can see, right, it's telling woof woof. So what exactly happens is, even though the parent class has the method called dog make sound, during runtime it will check which is the object that is calling the sound. So let's say instead of dog we can also have animal here. So if I click on this, it takes me to the animals make sound, correct? But while running, it gives me woof woof. That means during runtime, it predicts that this particular dog object is created using the dog class, and when we call a make sound, we should call the make sound method present inside the dog class instead of animal class. So this decision is made during runtime. So this is called runtime polymorphism or method overriding. So we are redefining the definition of the method that is available in the base class in the child class. You got the idea, right? So this is called compile time polymorphism and runtime polymorphism. Now, any doubt, guys? Or Ramod, you want to add anything up to it?
Uh, yes, Sudarshan. So I think you summarized well actually. And
Okay.
people, if you have any question, you can. So see, just what I will suggest that just ask the question. Just consider OOPS concept. Don't go that where we are using actually what is abstract class interface. Leave those things. We'll cover those things separately because understanding the OOPS concept is important. Because without understanding, you cannot implement or you cannot even explain. If I say the abstraction doesn't mean that you just need to use abstract class or interface. Okay, or if I say encapsulation, that doesn't mean that you just need to use private and everything is done. No, everything has deep meaning. Okay, so if you understand well this concept, then only you can explain well in interviews also. I see whenever I ask some basic question like okay, so why you're creating class? So there's such thing okay because I need to add main method or just I need to add notation or this is the way. No, that because there's some concept behind it. Why you create a class? Why you create an object of it? Everything comes from the OOPS concept. Okay, so understanding these concepts are important, not that creating a class, running a main method or running a adding a test engine annotation. That is not the actual OOPS concept. Means that doesn't define the actual concept. When you understand this basic terminology of OOPS, then only you see okay whenever you are writing a line of code, it exhibits some property of OOPS concept. Okay, so this was the first session on object-oriented concept. So we'll take separate sessions on like inheritance, polymorphism, then overloading, overriding. Those things we'll take in detail. So don't bother about those things. So this video has been already recorded. You can go through with this video again and again and collect the doubts. And you can point, you can mail or you can comment on the YouTube also. So whatever you want to do, you can do, but keep the OOPS concept clear because that is the first thing. And if you go to any service based, like product based companies or any startups, okay, so they focus on the core concept, how much you understand. They will not understand how well you can click because everyone knows that how to click using Selenium, but like how you construct a something which will be more proper utilization of click or send keys, right? All these concept can be implemented if you understand the OOPS concept. Okay, so stay with us. So it's just the beginning, and we'll go far. And if you this video will be recorded soon, sorry, uploaded soon on the YouTube channel. So you can go and if you have any question or if you think that we have misinterpreted something or we have taught something wrong, you can directly comment it. We are open for any feedback. Okay, and if you feel that any session or like how can we improve, okay, so you can give all the sessions there as well. Okay, so in the next session we are going to bring some good or more technical person for the session. So stay with us, we are trying to cover so many things for you people. Okay, so yeah, all the best. So if you have any question you can I will I will share my email ID where you can share the questions, and we can have a separate question and answer sessions as well where we can bring some good people like Mukesh Wadhwani or Naveen. Those things we can bring some good people and we can discuss on the question directly. So don't worry about those things. I will manage those things. Okay, perfect. So we'll
And
be winding up this session, and
Amod,
Hey, Ahmad,
hello.
Tuhin here.
Can
Ahmad,
you tell me the channel name?
it's retarget common.
Okay.
We'll sharing the details, so don't worry about that. Okay,
Ahmad, just like today you have taken the session, I mean, session happened. So it will be in the next Saturday, we can expect or Sunday.
yes, next Saturday Sunday because may most probably I will take the next session and then I'm approaching others also to take the sessions on that, or otherwise in between we can have Unix or SQL session in between also, like Docker, Kubernetes, like Jenkins end to end. Then these things also I'm planning. So maybe it may not be systematic, but yeah, it will be like topic wise, which is generally asked in interview. And even
And
we are
mostly
planning for the
in the
programming.
Saturday, right? And mostly is in the
Yeah,
Saturday. Okay.
yes, mostly Saturday, Sunday. We'll be
Okay.
deciding that in advance. And even also we're planning for the live programming solutions. Like some we'll select some programs and we'll take a live session on that. So that we'll show you that how you should start thinking before solving a problem. Okay, because if you go for any interview, they will not ask the basic questions of selenium. They will start from the java, how much well you understand the java, not even the reverse the string or get the count of the character in a string. No, they are much more than that. If you wish to crack the interview job like Amazon or Flipkart or Paytm, so you need to be good in data structure and those things. So we'll covering up all those concepts, so stay with us, and we'll bring the best. Okay.
Okay. Sure.
Thank you, everyone.
Cool.
Thanks so much.
Thank you, guys.
Thank you.
Thank you.
Thank you,
Thank you.
Ahmad and
Thank you.
Selvaraj.
Thank you.
Thank you, guys.
Thank you, Amod.
Thank you so much.
Thank you,
Thank you.
Sudharsan.
Thank you.
Thank you, Sudarshan.